Hello and welcome to XPages RDBMS support, What's New and a Partial Refresh. My name is Brian Gleeson and I'm a developer on the XPages team. The objective of this video is to demonstrate some of the changes to the relational database support in XPages that have recently gone into the extension library on OpenNTF. The video will also go over some of the basics of setting up and using this feature in XPages as a bit of a refresher, and so that this video can serve as a useful starting point for anyone new to the feature. So first up, the relational feature in XPages allows your XPages applications to connect to and interact with relational databases. XPages does this by leveraging the JDBC API in Java. So any database that has a JDBC driver available is thus able to be accessed by an XPages application. So combining XPages and relational databases can make for powerful applications, with the benefits of an XPages modern user interface and the power of a relational database in the background to store the data. Okay, let's take a look at the recent changes and additions to the XPages relational feature. The first of the changes was an infrastructural refactoring. Next, a new feature was added in the form of the JDBC driver plugin wizard. And thirdly, connection pooling support was added for Apache Commons DBCP. But back to the restructuring first. The relational feature was formerly part of XlibX, the experimental branch of the extension library, but it is now part of the main xlib. You can see this change in the different relational plugin names between older and newer xlib releases. So this means that the relational feature is installed by default when you install the extension library to your Domino server or to Domino Designer, and you need not install XlibX in order to use the relational feature. Note, however, that this change has a knock-on effect on any existing applications that used the old relational feature from XlibX. You will need to update your application to use the new feature. So open the XSP properties of your application, and in the Page Generation tab, deselect the XlibX library and select the new com.ibm.xsp.xlib.relational library. Save and rebuild the application. And if you have referenced any of the Java classes from the old relational feature in your application, those references will need to be updated as well. So for example, we have this class here, which is importing two classes from the old XlibX relational feature. So to update those, we simply remove the X. And now that they have the correct fully qualified class name, the errors will go away. For new applications, the relational library is not enabled by default, but you can manually enable it in the XSP properties, or you can drag on a relational control or a relational data source to the page, and it will automatically enable the relational library for you. The next change to cover is a new feature, namely the JDBC driver plugin wizard, which has been added to Domino Designer. In order for XPages applications to connect and interact with relational databases, the Domino server must provide the JDBC driver for the relevant database. JDBC drivers can be obtained from the database vendor or from a third-party provider. The wizard aids the process of adding JDBC drivers to your Domino server by generating an OSGI plugin wrapper for the JDBC driver. So let's take a look. Okay, here we have Domino Designer with the latest version of the extension library already installed. Under the Tools menu, we have a new option to launch the JDBC driver plugin wizard, which brings up this dialog, which has a number of different fields that need to be filled in. The type field, or the type drop-down at the top, you can select some popular relational databases, and this will fill in some default values into the class and plugin name fields below. Alternatively, you may leave the type field blank and fill in all of the other fields manually yourself. You need to browse for the JDBC driver that you have obtained. I have one on the desktop here for DB2 and add that. Then select a output directory. Let's put this one on the desktop here. And finally, you need to select whether you want to create a full update site or just a plugin jar. We'll go for the full update site and click Finish. The wizard generates an OSGI plugin wrapper for the JDBC driver, allowing for it to be easily installed to your Domino server. Here you can see the output of the wizard, an update site that contains a feature and a plugin, and having already installed it to my Domino server, you can see the installed plugin below. If you are familiar with using an update site to install the extension library, then it's just a matter of following the same steps to install this update site. The next update I want to cover is to connection pooling. Changes were made in release 5 of the 901 extension library to add Apache Commons DBCP connection pooling support, and to make it easier to add further pooling implementations in the future. Simply put, a connection pool is a pool of connections to a database that is maintained and allows connections to be reused. This increases performance, as creating connections can be expensive in terms of network traffic and processing time in connection initialization. In the XPages relational feature, there are currently two supported types of connection pool, simple and DBCP. The simple type is a simple connection pool implemented by the XPages runtime. The DBCP type is the Apache DBCP component, more specifically DBCP version 1.4. I'm briefly going to demo using each of the connection pool types. The simple connection pool is used by default. If you want to alter the settings of the simple pool, you can add parameters to the JDBC file in your application. For example, here we have set the maximum pool size to 3. Using the terminal on the lower half of the screen, I can monitor the connections to my database. So if I load the application, you can see that a single connection is opened. And if I start to use the @JDBC functions, you can see that more connections are opened, but never more than 3. I've now edited the JDBC file to use DBCP pooling instead, by changing the type and changing the parameters. For now we're going to set the max total and max idle to 3. I've cleared the connections, so let's reload the application. That connection is opened again, but this time it's using DBCP as the connection pool. So let's add some more items. And you can see the connection pool expands, but remains at the limit of 3. If I were to drop the values to 1 as the maximum and rebuild the app, then reload the application, only one connection is opened and is used for all requests. As you can see, no matter how many requests I make, they all go through the same connection. There are many more parameters that you can set for DBCP here. Consult the DBCP documentation for more info on available parameters that you can use. For the simple connection pool, it has a smaller set of parameters available, and you can consult the XPages extension library book for info on those. And that concludes the first part of this video, covering the recent changes to the relational feature in the extension library. This section is to serve as a refresher for the steps to set up and use the relational feature. If you're already familiar with how to do that, then you could skip this part of the video. If you're new to this feature or need to jog your memory, then stay tuned. The first step is to install the latest version of the extension library to your Domino server and to Domino Designer. The relational feature became part of the main xlib in release 7 of the 901 xlib, so it is assumed in this video that you are running 901. The second step is to use the JDBC driver plugin wizard to install JDBC drivers to your server. I already covered how to use the wizard in the first part of this video, so we'll move on. Next, you need to create a JDBC file in your application. Each JDBC file represents one single connection to a relational database, and you can create a number of JDBC files in your application if you choose. Within the web INF folder, which is under the web content folder, you need to create a new folder called JDBC, and in that folder create your JDBC file. You will need to use the Navigator or Package Explorer view in Designer in order to access the web content folder of your application. Then you'll need to fill in the contents of the JDBC file. So let's switch over to an example I created to understand what's needed in that JDBC file. This JDBC file, called db2.jdbc, defines a connection to an IBM DB2 database. Using XML tags, we define the parameters of the JDBC connection within a single JDBC tag. The driver parameter refers to the driver class within the JDBC driver that returns the connection object. You'll need to refer to the documentation of the JDBC driver you are using to discover which class to use here. This example shows the class used by the JDBC driver provided by DB2. The next parameter is the URL to use to create the connection. Each database has its own specifications for the makeup of this URL. In this case, it starts with jdbc:/db2:, followed by the server address, the port number, and the database name. Again, consult the documentation of your database for information on constructing this URL parameter. Lastly, we provide the login details to be used to connect to the database in the form of the username and password. So this comprises a basic example of the contents of your JDBC file. The next step is to add the relational library to your application in the XSP properties. You can do this manually, or it will be added automatically by performing the sixth step listed here. Let's take a look at adding a relational data source to an XPage. Here I have a demo application which I've set up to use the application layout control as a base, and I've added some placeholder pages to it. Currently these pages are empty, so let's switch over to Designer. And as you can see in the XSP properties of the application, the relational library is not selected. Here we have the DB2 main XPage, so let's add a panel to this page. In the panel properties, we'll switch to the Data tab, and let's select a JDBC query data source. As you can see, a dialog pops up asking if you want to enable this library in your XSP properties. If I switch back to the XSP properties, in the page generation tab, you can see that that library has now been added automatically. We need to set the connection name property of the JDBC query data source to the name of one of the JDBC files that we have in our application. As you can see, I have a db2.jdbc file here in my JDBC folder. Then I'm going to specify a table from my DB2 database in the SQL table property of the data source. You could instead use the SQL query property to pass in an SQL query to retrieve what you want from the database, or you could pass in the name of an SQL file contained in your NSF to do the same. Once the data source is in place, controls can reference it and use it to pull data from the database. So this makes up step 7 on our list. Let's switch over to a more complete version of this same application to show you a data view utilizing the relational data source. Okay, here's the finished data view. In the value property, we reference the variable name assigned to the JDBC query data source. Then salary, name, and ID are columns in the staff table that we want to display in our view. I've also applied some styling, a currency converter, and added a pager to the view as well. So let's take a look at the result. Here you can see the view showing the list of data from the staff table in my DB2 database, with the name and ID on the left hand side and the salary column on the right. Now let's add some more controls so that we can change data in the database. I have a pre-cooked button panel that I'm going to uncomment here. This panel adds some text fields and buttons that utilize the @functions provided in the relational feature for JDBC functions. First is a delete button. This uses @JDBC_delete to delete a record from the database. The function takes the connection name, which is the name of the JDBC file, and the table name. Note here that I have stored those values in viewScope variables on the XPage. The delete @function also takes a where parameter, which acts the same as the where in a SQL query. In this case, we are asking for the record with an ID equal to the one passed in from the ID choice edit box. I've also added some fault tolerance here as well. So in the application, if I click the delete button without an ID entered in the field to the left, I get an error. If I enter an ID that doesn't exist, I also get an error. And if I pick ID equals 20 and click delete, it deletes the first row from the view. And this has also been deleted in the backend database. Moving back to the source code, the second button can be used to deduct salary from underperforming employees. And it uses two different @ functions. The first is @JDBC execute query to retrieve the relevant record that we want to update. The function takes the JDBC connection file name and an SQL query. Once the record has been retrieved, we pull out the salary value, convert it to a number, subtract 10,000, and then we use the @JDBC update function to pass in the change. The update function takes the JDBC file name, the table name, the new values, and the where parameter. So let's see that in action. If we pick Marge from the table below with ID 40, we can deduct salary from Marge as much as we want until she has only €8,006 to live on per year. The third and final button is the insert button. This uses the @JDBC insert function to insert a new record into the database. The function takes the JDBC file name, the table name, and the values that we want to pass in. This will create a new record in the database, which has been set up to automatically generate the ID value for new records. So if we enter a name and salary and click the insert button, and we can see the new record has been inserted into the database below. I have also added XPages to the application with the same functionality for Microsoft SQL Server and MySQL. These pages utilize separate JDBC files in order to create the connections to those databases, as you can see here in Designer. Each page displays a view of data from the database tailored to the tables and columns in that relevant database. And we can use the @function buttons here to perform similar actions as we did with the DB2 database. And here we can see the same functionality on the MySQL server. In each case, I downloaded a JDBC driver for the database, used the JDBC driver plugin wizard to create an update site, and installed the update site to my server. So this shows you that you can interact with a number of different databases in the same application, as long as the server has access to the JDBC driver for that database. Well, that brings us to the end of this video, which I hope has been helpful. If there is enough demand, further videos could be made to explore some more of the relational features and how to use them. Or if you have any questions, you can reach me with the contact details listed here. Thanks for watching and good luck!